Hello, everyone. Welcome and thank you for uh, joining us today. Thank you, Gianluca, John, Ashley, and others for organizing this event. So I'm very happy to share some recent research with you. But before that, just a little bit about myself. So my name is Ali Makhdoumi, and I'm an associate professor of decision sciences at Fuqua School of Business, Duke University. I work on market design, platform operations, and more recently, data markets and privacy. And today I will be talking about the issues of data markets and AI, and in particular, so I will discuss a very recent paper, a model of behavioral manipulation that we wrote together with Daron Asamoglu from MIT Econ, Azarakhsh Malekian from University of Toronto, and Asuman Ozdaglar from MIT ECS. But before we get started, please feel free to ask questions. So I'm monitoring the comment section here on another screen. So please leave your questions in the comment section. I would be more than happy to answer them. All right, so let me share my slides and get started. So again, this is a joint work with Daron Asamoglu, Azar Khmelikian, and Asuman Ozdaglar. So this is it's probably a little bit more theoretical than what may have been ideal for a general discussion. But there's a reason for this theoretical investigation. So the way I think about it is, there's a very clear growing data collection and advances in associated tools for data analysis that is now shaping every aspect of our economy, education, and social life. And what its broader social implications are is sort of very difficult to ascertain because this is a sort of a unique episode that we are seeing, and this is a sense in which we want to think about a lot of things that are not in the planned course of actions, or at least we do not hear about them much, but might still have broad social implications. So I think theorists will have a lot to say in this area that can complement the studies that people in the legal sciences and sociology have been doing. And so, for example, Shoshana Zuboff, in a great book, In the Age of Surveillance Capitalism, claims that companies are creating a new system in which human experience is used as free material for hidden commercial practice process of extraction, prediction, and sales. And this leads to an extraction of behavioral surplus created by behavioral modification. And even more clear are two legal scholars, Hansen and Kaiser, that sort of argue, once one accepts that individuals systematically behave in non-rational ways, it follows from an economic perspective that others will exploit those tendencies for gain. And once you sort of put these together with the greater ability of platforms to collect information, perhaps they will have more ways to exploit these tendencies for gain. But once you start thinking about it, you realize, well, yes, so greater information means that platforms will modify user behavior, but is that really bad for users? After all, personalized recommendation, advertising, and services all create certain modification of behavior, and one can argue, they help users. So I think it's important to have sort of both theoretical and empirical research to sort of investigate that. When is it that changes in the behavior of consumers because of the platform's information advantage are good for them, or bad for them? And that's what this paper and this talk will do. So we want to evaluate these issues from a theoretical perspective. So we want to sort of have a model of behavioral modification, and in particular, see when behavioral modification turns into behavioral manipulation. So there are lots of motivating examples but let me sort of jump over them because I think they're very familiar. Um, but even before the age of like generative AI, many companies were predicting when certain population are more vulnerable, and when they're going to have demand for certain products, and we're trying to use that information to sort of make the product look more attractive. So there are a lot of things going on in each of these applications, but I think the common feature in all of these applications is that the sellers or the platforms, they have superior information, and they can use that to manipulate user behavior, and this could be perhaps not so good for the users. So we think that sort of a good framework for analyzing this question is an online experimentation system where uh, consumers can learn about what their preferences are from experimentation with different products, like which services or products do I want to use, or the product choices that I'll have. But importantly, these product choices, and therefore the whole sort of experimentation, is guided by the platform. And in particular, the platform chooses one of multiple products, so let's say one of n products, to offer with an associated price. A product can be good or bad for the consumer, and she finds out about that as she consumes the product, as she uses the service. So that's a classic experimentation, and this implies there is a joint experimentation problem. But here we add sort of three new elements to it. So first, the learning is going to be affected by something we call the glossiness of a product. And by glossiness, we mean something that is not inherently the quality of the product, but changes the signal distribution, changes the sort of the information that the consumer and the platform are going to observe. Second, the platform, after the use of AI tools and big data analysis, can learn more about these demographic group preferences and tendencies than the consumer herself, and in particular about the glossiness of a product. So we think of whether I like a product, or whether I like a service or not, is idiosyncratic to me, but there are certain critical aspects of which products are going to appear good for a while to consumer that the platform can learn, that the platform can predict, by having access to more information than the users. So we're going to denote this glossiness by some parameter alpha IT. And glossy products, those are the products that start with alpha being 1, meaning they can fool you for a while, so they look glossy for a while, and that's what the platforms are going to be able to recognize and most likely use it for their gain. And then we're going to look for behavioral Nash equilibrium of this experimentation game, where the only behavioral elements, which I think is very common in reality, is that consumers don't understand how much information the platforms have, but other than that, they're going to be fully rational. So I guess if I had more time, I would go to more of a discussion of the literature here. But there are actually like a lot of evidence in the marketing literature about impulse buying, hidden costs, and cognitive manipulation, and these have important demographic sort of group specific elements. And those are the things that the platforms can learn about, and they can predict it. And I'm going to go sort of through three main results. Let me mention them here verbally, and then we'll have sort of a more formal version of this toward the end to help with the intuition. So first, something that sort of confirms the common view in this literature. More data and superior information for the platform can make the user better off, and that is going to be the case when this glossiness that I mentioned lasts only for a short period. So when glossiness is short-lived, then more data is going to help the users. Um, why is that? So when the glossiness is short-lived, so it means that the platform cannot fool consumers for a long time. So even if they have some incorrect inferences, that is going to go away. So in that case, the platform actually does not want to fool people, and I will explain the intuition sort of more formally later. Second, if the glossiness is more persistent, so it lasts for a sort of a long period, then it becomes profitable for the platform to engage in behavioral manipulation, and this is profitable for the platform, but bad for the consumers and also for the utilitarian welfare. And third, things get worse when there are more products on the platform. So if you think of new AI powered platforms as both having a lot of information and also being able to offer many products, then there is a sort of a double whammy going on here, because more products means more options for manipulation, and also technically, in terms of the analysis, so our experimentation game means that we have to develop sort of new analysis of this experimentation problem, because one party is guiding the other with different information sets, which sort of will become more clear throughout the talk. And if time permits, toward the end, so I will sort of discuss the policy and regulation implications as well. All right, so let me skip the related literature. I mentioned a few of these works earlier. Also, behavioral industrial organization that's relevant to us, and also, harmful effects of information because of, either surveillance or price discrimination. But one thing I want to highlight here, so here we are sort of identifying a new issue related to harmful effects of information, and that's what we call behavioral manipulation. And the other harmful effects, such as surveillance or price discrimination, has been identified in the literature, so we're adding to that list. All right, let me jump to the model. So again, my purpose is not to go to the detail, but giving a little bit of formalism is useful, I guess, for building the intuition, and we can discuss, how that intuition is useful or perhaps not for the next steps. So we consider a continuous time, infinite horizon economy, and the platform has multiple products. So let's say n products, and we're going to consider a single user interacting with it. And for the user, the product has quality theta I and glossiness alpha IT. And as I explained, this glossiness is going to capture all things related to impulse buying, delayed cost, and so on. So together with product I, the platform also offers a price, PIT, and we're going to have three types of products that could be offered, and that determines the kind of information that will be revealed as well. So if theta I is 0, which means the product is low quality, and alpha IT is 0, so it's not a glossy product. So in that case, in a sort of a typical exponential banded fashion, there's a Poisson process at some rate gamma, which is going to reveal this is a bad product. And the second case is the theta I is 0, meaning again the product is low quality, but now alpha IT is 1, meaning the product is glossy. Then the user is not going to receive bad news. So this glossiness is going to sort of hide any bad news that you're going to see about this product. And finally, if the product is good, this theta I is equal to 1, then that's a high quality product, and the user does not receive bad news. So this is a model in which all news are going to be bad news. Now, this glossiness is not forever. So this means we cannot fool people all the time. So glossiness is going to wear out, and the consumer will realize at some point, yes, so this delayed cost, I've seen this before, or this great advertisement is not perhaps making sense. So alpha IT is going to transition from 1 to 0 at some rate rho, and in particular, if a product starts non-glossy, so it's going to stay non-glossy, but if it starts glossy, which has some probability lambda, it's going to transition to a non-glossy regular product at some point. So again, glossiness is not going to stay forever. At some point, a glossy product will transition to a regular product. And here are the key sort of informational assumptions we're going to have. So we're going to assume no agent observes theta I. So not the user, not the platform. So these are going to be idiosyncratic preferences. And in the pre-AI environment, no agent observes alpha IT, the glossiness. But in the post-AI environment, the platform can perfectly estimate this alpha IT. So this alpha I0, so this initial glossiness. So importantly, the platform, so now I'm not going to assume the platform observes the entire trajectory, this alpha IT, only the initial state. And we'll see, that's enough for, performing behavioral manipulation. So the platform only knows the initial, tendencies as it, so when it comes to, knowing this glossiness. And the payoffs are very simple. So the user has utility theta I minus the price, quality minus price, and the profit, is the offered price for the platform, and we're assuming zero cost of producing, and everybody is going to discount the future at some rate R. And again, in terms of the solution concept, so we're going to look at Markov-Nash equilibrium, meaning each agent takes the optimal decision given the current beliefs about the product qualities, sort of taking into account the future. And again, the only behavioral element in our model is that consumers do not learn from the platform's action. All right, so let me mention the sort of the sort of a key technical steps here without going over them, and then I will jump to the results. So we first characterize the learning trajectory of the platform and the user. We then formulate the platform's problem as a sort of a stochastic dynamic programming. This turns out to be quite challenging, but the way we deal with it is to sort of rely on Gittins index characterization and sort of trying to obtain structural properties of the Gittins index. So hopefully, this has convinced you there are new technical elements here as well, but that's not the sort of a main point of this talk. So I want to sort of focus mostly on the results. So let me talk about the main results now. Okay, now I can sort of highlight the two forces that are going in opposite direction in this environment. So first, there's a manipulation effect. So if rho is small, which means that glossy products stay glossy for a long period, then the platform manipulates the user in the sense that the platform offers products that are glossy, even if they have a lower belief. So why is that? Because the consumer gets good news for a while, and because they get good news, their belief increases, and the platform can exploit that. But there is a sort of the opposite phenomena going on as well, and that's what we call the helpfulness effect. So if rho is large, or is very high, which means that glossy products are going to stay glossy for a short period only, then the platform does not offer glossy products, even if they have higher beliefs. And this is helpful because the platform knows that the glossy products are not good. So I actually modify your behavior in a helpful way, guiding you sort of away from the glossy products. So that's like a platform that knows, the low quality products and discourages you from consuming the low quality products. But putting these two effects together, we're going to sort of look at the utility post and pre AI, and in all the comparison that I'm gonna mention. So we're going to evaluate these utilities using the platform information set. Why is that? Because the platform has more information, and that's going to be sort of more relevant for your flow of utility. So let me give you sort of three results, and then I will conclude. So result number one. So if row is large enough, so again, this means glossiness is short lived, then AI is going to improve the platform's profit. The platform having this information advantage is going to help the platform to sort of improve its profit. It's going to improve user utility, and it will also improve utilitarian welfare. So in this case, when row is large enough, and this glossiness is short lived, so this helpfulness effect dominates, and you sort of avoid users going into the glossy low quality products, and everybody gains. So this is like the best case for advertisers, informative advertising in some sense. And this also confirms the common wisdom, in this literature that with more data, users are going to gain. But if this row is small, if glossiness is sort of long lived, is sort of long lived, then the platform still gains, but both the user utility and the utilitarian welfare are going to be lower in post AI compared to pre AI. So now this manipulation effect is going to kick in. So you're sort of pushing users toward glossy products. So in the medium run, you can exploit that information. So I think this is one of the main results. So let me sort of spend some time to sort of explain the intuition here. So I think it will be useful. So behavioral manipulation takes place when we have a low quality product which is glossy. Why is that? Because the platform knows that it will take a while for the user to understand this. Recall that row here is small, so bad news are masked for a long time. So row being small means bad news are masked for a long time. So in fact, the platform may offer a glossy, low quality product, even if the user belief for it and therefore the user willingness to pay for it is small. So this hurts the platform payoff in the short run, but in the long run, the platform will be able to charge higher prices and sort of compensate for it. So the key is that this is not a permanent exploitation. So for a while they will be fooled, and then they will learn this is a low quality product. But you as the platform, you don't care because you're going to switch to another product and repeat the same process over and over. Let me now give you the final result. So result number 3. So let's focus on the sort of a post-AI environment and see what happens as we increase the number of products. So this result says that the platform gains, but for small enough row where manipulation effect kicks in, both the user utility and the utilitarian welfare, they're going to decrease. And this is because, with more products, the platform will be able to exercise the behavioral manipulation, more. And the way I would like to think about this result, or the way I would like to interpret this result, is that there's a double whammy of AI or data. So now with more information and more data, there are better ways to find glossy products, and also better estimations of their glossiness. So large platforms not only can estimate your tendencies, but can also pull across many different products, and that can become dangerous. All right, so let me sort of end with a brief discussion of public policy. So the problem is that of course, you may not buy our model, or you may not buy that there is a problem. But suppose you buy the main research direction that there is a problem like the one that we are identifying here. Um, then how to fix it is very unclear. So, providing information to consumers uh, may not work because, first of all, the users may not be able to process the same amount of information as the platforms, and if they do, still they have behavioral tendencies. Competition also is not clearly useful. Why is that? Because once someone sort of joins a platform, then the same manipulation will take place because of the glossy products there. And in fact, competition may worsen the situation because it's going to encourage platforms to go after glossy products, more intensely. So competition is not necessarily an easy thing to work with under these circumstances. And preventing the harvesting of user information is not easy or may not be desirable. Certainly there are benefits to AI and data-powered platforms. So we're not saying, it always hurts uh, consumers, but rather there are certain mechanisms that can hurt users, and that first of all we should know about them, and then try to reduce their impacts. And also there are so many information streams, and it's not clear how one can put a stop into harvesting the user information. So I think we need new regulations to be able to deal with this problem. And in some other works with the same co-authors in similar settings, so we have suggested some ideas for that, but they may not actually translate to this setting. So this is pretty much an open research direction here. All right, so let me conclude here. So I guess there are a lot of issues here, and I think we're just scratching the surface. This is our first attempt to model behavior manipulation from a sort of information theoretic angle. The platform has more information than the users. There are many interesting directions to explore, and I would be more than happy to talk about them in the Q&A. I already see some questions there. So let me stop here. And thank you again. And comments are, of course, very much welcome. So I'm going to go to the questions that we've got here. So there's a question from Stefan here. Let me see. Very good. So that's a very good. So the question is, here I'm assuming that the platform can perfectly estimate the glossiness. So the question is, well, what if that's not perfect? So I made the assumption to simplify the analysis, but this same sort of phenomena will happen even if the platform has some estimate of that. As long as that estimate is accurate enough, then we still see that the platform can engage in behavior manipulation. Again, the kind of forces we identified here, both the manipulation effect and the helpfulness effect, will be in place in that case as well. So the assumption that the platform observes the glossiness fully or can estimate that perfectly is just for simplification. The same thing will go through even if that's imperfect. Right. So the question is, how should I think about sort of real life examples of this model? So I guess I kept it as an abstract model, I guess on purpose. But you can think about e-commerce platforms or in the streaming platforms, and because the detail of each one of those is like very specific to themselves. But what a few things I want to sort of highlight. So what is it that we're capturing in our model? So we're capturing the fact that first of all, the platform can offer from a menu of products, the The platform can offer many different products, and that's true for many platforms. And the other thing is that platform has more information than the users, and that we can, I guess, agree that it holds for many platforms. And that the platform is going to use that information for their gain. And I guess that's where we can sort of discuss whether we agree or not. But if we have that as well, then basically this model applies to any setting with those features. In any setting that the platform offers multiple products, the platform has more information, and is going to use that information for their gain. So the same thing will happen there as well. So very good. So there is another question about how should I think about big companies versus small companies. That's a great question, and that's actually something that we are sort of exploring in a sort of like a work in progress. So here I'm actually assuming that the company is big enough, has a lot of data streams, and can sort of estimate these glossiness perfectly. But what happens when you have competition? You have small companies and big companies, and they're competing with each other. So what's important there is in the companies, so they're not only competing for the consumers, but they're also competing for the data of the consumers. So this it's a competition sort of for data and by data. So that's how I like to think about it. And it's a quite interesting, question to sort of see, what will happen if you have, small companies that perhaps, have a better quality product, but, have less access to data streams. How would the competition of that company with a larger company in terms of the data, but perhaps a lower quality product would work. So again, very interesting question in terms of the competition between big companies and small companies. When you think about they're not competing only for the consumers, but also for the data of the consumers. So it's a super interesting direction to study. And yeah, so thanks for that question. Very good. So I guess the question is, how can we mitigate, the risk that we're seeing? So again, it goes back to the discussion we had on the public policy. So I think the main issue here is that there are two things that are happening at the same time. So one is, the platforms have, access to a lot of data about users, and they can use that. And the other thing is, they can sort of tailor the experience of each user. So, and once you put these two together, then you see this sort of behavior manipulation. And if we want to avoid behavior manipulation, then we can work with any of these levers. So what do I mean by that? So we sort of limit the access to users' data. So that certainly reduce the effects of behavior manipulation. Or the other thing is we limit the way the platforms can offer targeted or personalized services. So we put a limit on that. So we say you cannot sort of take it to the extreme, and that also is going to help to sort of reduce the behavior manipulation kind of things that we saw in this model as well. But again, in terms of the policy and regulation, so it's still, again, as I mentioned, it's a very interesting open direction. So we don't have a concrete solution in mind, and I think it's a good thing to it's a very interesting direction to think about. Thank you so much. So I guess there are no more questions. Yeah, thanks so much again for joining us. So one thing before we wrap up. So next month, please join Professor Nuno Clara on Wednesday, February 7th at 12:30 for a discussion on the role of regulation on house energy efficiencies. Thanks so much again.